Okay, you guys just finished up chapter 2. Okay, we're starting chapter 3 and it's called Real Numbers and the Pythagorean Theorem. Okay, the first 2 sections are called square roots and estimating square roots. Okay, so we're going to deal a lot with squares this chapter. Okay, so what do you hear in square roots? What word do you hear?
Square.
Square. Right, so it's going to have to do with squares. Okay, what are some of the properties we know about squares? Connor?
They have 4 even sides.
They have 4 even sides. What else? What else do we know about squares? Evelyn? They're what? Their shape. Okay, what other properties do we know about them? Jalen?
They're a unit in math.
Sorry?
They're a unit in math.
A unit in math. Oh, so like something squared? Okay, so we can square a number. Okay, Alexia? They have 4 right angles. Okay, what do we know about their area? How do we find the area of a square? Nigel? L times W, so length times width. Okay, more specifically, for a square, length and width are what? Are they equal or are they different numbers? They're equal? So for, oh, is that an extra? I don't know if I gave you enough. Okay. So for a square, okay, let's write this down somewhere. So we know for a square has 4 equal sides, right? The lengths are all equal. And Nigel said the area of a square is length times width. Okay, but what do we know specifically about length and width?
Y and X axis.
Sorry?
Y and X axis. Those are the Y and X axis.
The y-axis and the x-axis.
Okay, what do we know about these specific lengths?
They're all equal.
They're all equal. So length is equal to width for a square, right? If you have a square, the length and the width are equal because all 4 sides are equal. So how else can we write the area? What's another, Darnell? Base times height, but we know base and height are equal. So what's another way we can write it? Sophia? Okay, did you hear that? She said length squared or width squared. So let's just write it. If we had a square, and this is just a side length, right? That's some side length. We can just write it side squared, right? Because it's the same length. So she said you could pick length squared or width squared, but since those are the same thing, length and width are equal, I'm just going to call it side. And we can call it side squared to find the area. Okay, so I just passed out those papers. So look on these papers. The length from each dot, so like up and down, let's call it 1 inch. And let's call going horizontally 1 inch. So I want you to find or draw a square that has an area of 4 inches squared. And then I want you to prove to yourself and to me that what you found has an area of 4 square inches.
Like anywhere on here?
Yeah, anywhere on there.
4 squared.
Yeah, because so inches times inches is inches squared, right? So if this was something inches and this was something inches, when you multiply it, you have to get 4 inches. So how many boxes are inside? So how many boxes do you have inside? Do you have 4? So the area should be 4 little squares. So the area should be 4 squares. So that's 9. Okay, up here. Okay, look up here. So, what is the area of this box right here?
1 inch.
That's 1 by 1, so it's 1, right? Okay, and if I have, so what would I need to do for an area that has a 4? It needs to have 4 of these little boxes inside. So So Jalen, what would I do? Tell me which way to go.
You would go down 3.
2 spaces.
Yeah, 2 spaces.
So 1, 2. And how many am I gonna go across?
2.
1, 2.
You're gonna go up 2. And yeah.
Okay, so they all need to be equal. So now I'm gonna prove that this is, in fact, 4 square inches. So I see 1, 2, 3, 4. Is this area 4 square inches?
Yes.
Okay, what is the side length right here?
2. Well. 2.
2. Okay, so I went 1, 2. So it's 2 inches. Okay, how much is this one right here?
2. 2.
How many is it? So here's 1, here's 2,
2.
so it's 2. Okay, did everyone follow this? Okay, I want you to make a square that has an area of 9 square inches. Okay, so 9 square inches. Okay. I think I saw most of you got it. So there's actually, I saw some of you guys did it different ways. So one way would be, some people did like this. They made 9 of these square boxes. Okay, and what do we know about a square? They have to have all equal sides. Okay, so that was poorly drawn, but you can see there's 9 boxes, right?
Yes.
Okay, what is our side length?
3.
Yeah, 1, 2, 3. So this whole side length is 3. What about this one?
3.
3. Okay, so have we proven that this is a square? Here, I'm going to put this up on the board. I forgot. Okay, so this is an area, a square with an area of 4 square inches. Okay, what is the side length?
1.
We just did this one. What's
2.
the side length?
2.
2, right? 2 inches. Okay, and what was the area?
4 inches squared.
4 inches squared. Okay, here is a square, like we just found. It has 9. It's 9 inches squared. Okay. What was the side length? 3 inches. Okay, what was the area?
9 inches squared.
Okay, I want you guys to find a square that has an area of 16 square inches. So count how many boxes are in there. Remember, squares have to be equal on all 4 sides. Where is it? That was a 9. But I'm gonna, you checked it out. Yep. Okay. So for 16, an area of 16 inches squared, I would need 16 of these little boxes, right? Okay, I'm not going to draw all 16. Someone tell me, how many should I go down? Kelly? So 4 spaces, 1 each. And how many should I go across? 4. Okay, and if I filled it in, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So does it have an area of 16 square inches?
Yes.
Okay, and what is the side length?
4.
And what is this side length?
4.
Okay, let's put that too. So here's a square with an area of 16. So area is 16 inches squared. What's the side length? 4 inches. Okay, one more. I want you to find me a square that has an area of 8 square inches. So an area of 8 square inches. Okay, think about it. Take some time. Remember how you guys filled in boxes? So you made, like, you counted out 16 boxes to do 16. Okay, this one's going to take some creativity. Okay, what are the properties of a square again? All 4 sides are equal.
Oh.
I want a square, not a rectangle. I want a square with an area of 8. Okay, remember the properties of a square. All 4 sides have to be equal. They gotta have right angles. And side squared has to equal 8. Okay, I'm gonna give you a hint. What if can I draw squares diagonally?
Yeah.
Is that still a square?
Oh,
Okay. What about, okay, what do you think the area of this square is?
9.
Okay, write it down. Draw this one. And find the area of that square. Okay, draw this one on your paper and find the area of this square.
Here.
And then prove to me that once you have the area, that is the area, okay? So find the area, and then I'm gonna walk around. Okay, Lucian, I want you to come up to us and explain. You can come up here and write down if you need to. Explain why this one has an area of 8 inches, 8 square inches.
Okay. If you draw it down like this. Oh, sorry. You can count them. These only equal like 1/2, so
How do you know that they only equal 1/2?
because if you put them together sideways, you get a square. So you count them by 2s, and it equals 1. That. So 1, 2, 3, 4, and then you add the other 4, and you get 8.
Okay, so label those inside ones, 1, 2, 3, 4. Then, yeah. Okay, so we see there's 4. So we know it's more than 4, right? We all agreed it was more than 4 square inches. We can see. Okay, there's a little bit more. And how did we discover the other ones? What did you say they were? They're each a half.
Yeah.
Okay, so okay, you guys just learned how to add fractions, right? You even learned how to multiply. So I see 1, 2, 3, 4, 5, 6, 7, 8 halves. What does 8 halves add up to, Sean? 4. Okay, so 4 plus 4 is? We found a square. Oh, thanks, Lucian. You can sit down. We found a square. Thank you. That has an area of 8 square inches. Okay, so here's one. Okay, looks smaller than that. Looks bigger than that, so I'm going to put it right here. Okay. And I know the area is equal to 8 inches squared. What is the side equal to? 2. Okay, let's put down some people. Okay, so someone said 2. What else?
2.5.
2.5? Shh. What else? Who else has a guess? Serenity, what do you think? Do you have a guess? Just throw a guess out. Okay, any other guesses? We just have 2 guesses? 3? Okay, what's another guess? Any other guesses? Okay, let's try some of these. Okay, how did we go from, so what did we do to get the area?
3.
We squared it, right? So we squared 3 and we got 9. We squared 4, we got 16. Squared 2 and we got 4. Okay, let's square 2. 2 squares. What is that?
4.
4. That's too small, right?
Yes.
Okay, so let's come up with our, so we've got 2 small, and we've got 2 big. We want something that is exactly 8 inches squared. Okay, so 2 squared was too small. Okay, let's do 3 squared. What's 3 squared?
9.
That's too big, right? Okay, 3 squared was too big. So someone said 2.5. Let's
Yeah,
do
right
2.5
here.
squared. 2.5 squared is 6.25. Is that 8?
No.
Okay, so it's too small. So 2.5 squared is too small. Let's try another one. Nathan.
2.7.
He says 2.7. 2.7 squared is 7.29.
4?
4? Okay, what's 4 squared?
Oh,
16, that's way too big, right?
2.8.
2.8? Okay, 2.8 squared is 7.84. Still too small. 2.4? 3.1. Okay, we already know 3 is too big, so I think 3.1 is still going to be too big. 2.95? Okay, that's 2.95 squared is 8.7025. That's too big. So 2.9, what'd you say, 9? 95? Too big.
3.0.
Okay, we already tried 3.0.
Oh, 2.85.
Okay, let's do 2.85 squared. Okay, we get 8.1225. So 2.85, too big.
2.82. Okay, I messed
2.82?
that totally up.
2.82 squared is 7.9524. So 2.82, too small. 2.83?
Oh,
8.0089. So 2.83 is too big.
I don't know.
Okay, what are we finding? Okay, hold on.
8.
Okay, so Roberto says we should just keep adding decimals, right? We should just keep adding 2.821, 2.8213. You can keep going, right? What are we? Okay. Shh. Okay, what we have found is a number that cannot be written as a decimal or fraction. Okay, do you guys remember this? Okay, look up here. You guys remember we started learning about real numbers, right?
Yeah, we can't see.
People are down.
Sorry. Okay, real numbers. Okay, they're made up of 2 things. We've got rational numbers. Do you guys remember what's a rational number? Raise your hand if you know what a rational number is. Lucas, what's a rational number? Remember, we just finished the chapter on this. It has the word ratio in it. It was a vocab word last chapter. Rational numbers. What's a rational number? Shania? Do you know? It has the word ratio in it. That's your hint. So, what's a rational number? 3. Okay, 3 is an example of a rational number. What's the definition of rational number? It's a number that can be written as
A decimal.
a fraction or a decimal. Okay, so we have rational numbers. So what do you think an irrational number is? Okay, remember from your English class, what is ear? What does ear mean? The prefix?
Body.
It means, no, IR.
Just kidding.
It means what?
Can't.
Can't? Not? Right? So not rational, what is that going to mean? What is not rational?
Remember that?
Can't be charged until.
Okay, a number that cannot be written, good job Aramis, a number that cannot be written as a fraction or a decimal. Okay, so let's look back up here. So these numbers we were able to write, right? Okay, so someone said, let's take have you guys heard of a square root?
Yes.
Have you heard of square root?
Yeah.
Okay, so square root is an inverse operation of something squared. So the square root of 16 is 4. Square root of 9 is 3. Square root of 4 is 2. What's the square root of 8?
4 now.
No.
It is.
Okay, let's put it in the calculator.
5.
Square root of 8 equals 2.828427125, and it's going to keep going. It says ... So, it's not repeating. I don't hear a pattern.
So is it basically like pi?
Yes. Did everyone hear that? Pi is an irrational number. You guys remember pi? Pi is an irrational number. Guess what else is an irrational number? Square root of 8. Okay, square root of 8, that's why we're having such a hard time finding a number, a decimal to represent square root of 8. Because there isn't a decimal. We can approximate it. We can approximate it all we want, but but is there an exact decimal or fraction?
No.
No, because the number is irrational. Okay? So, what is the side length of this square? Yeah.
Well, 1? No.
Okay, let me show you this first. Let's write this. Okay. So, to go from side to area, we squared it, right? 4 squared was 16. Okay, the inverse operation of square is square root, right? So I can rewrite this as, I want to know the side is the square root of 16. Here, the side is the square root of 9. The side here is the square root of 4. Okay, but these numbers, what do these numbers have in common? 16, 8, or 16, 9, and 4.
Well, they're all numbers that can be like they have like a whole number, like not a decimal, like continue on like pi
Okay.
now.
Okay, so Cora,
They all have a square root.
they all have a square root. So every number has a square root,
That's
just not rational or irrational. Okay, so I think what you guys are, did you guys read your chapter? It's a vocab word.
Yes.
It's a vocab word. What are all these numbers?
Oh.
Starts with a P.
Oh.
perfect square.
Perfect squares. Okay, so these numbers are all
Yeah, I got
perfect squares. So we don't have to write them like this. We can actually solve the square root of 16. The square root of 16 is 4. Square root of 9 is
3.
okay, these are rational numbers, right? These are rational numbers because I can write, they actually evaluate to something. So what is the side length of this one? Okay, so you guys saw how I found the side length for these. So my area is 8, so my side length is going to be what?
2 point.
No?
Oh.
Okay, I put it in a square root, right? So what's, the square root of the area was my side length. So what's the square root, what's the side length of this one? Matthew, do you know? Cora?
Square root of 8.
Square root of 8. Okay, can this be evaluated? No, we can leave it like this, right? Okay, so get used to this is called the radical sign, the radicand. So, write this down, the radical sign, and it looks like this, square root. Okay, this means positive square root. It's a positive square root of a number. Okay, write it down in your notes. So, square root of 8, we can approximate it. So what did we find out? That the square root of 8 was approximately 2.82847, and it's going to go on forever. Okay, there's no way we're going to write this down on our paper. It would take forever. We can approximate it like this, or we can just write it like this. And this is the exact number. They had to create something. So like pi, it's 3.14, and then it just goes on for a billion numbers, right? So they didn't want to write that down every time, so they created a symbol, that little funky thing. They created a symbol so we could just write it down and save space. So same thing. They didn't want to have to write down 2.82847. So they created a square root sign, and we could just write square root of 8.